Chapter 6 is going over fractions and being able to compare them, and the students have learned many different strategies to compare them, and they've been doing very well with it. So I just want to share those with you to be able to help them at home with comparing fractions. So the first one, the first strategy is using benchmarks, and benchmarks is comparing things to if it's closer to 0, a half, or a whole. And so I'm going to look at my fractions up here, and I'm going to look to see if anything's really close to 0. And I noticed that 1/3 hasn't hit the halfway point on my number line, so I'm just going to plop this down on this side. Now, it's not going to be super accurate where it's at on the number line, but at least I know it is less than a half. My next clue is to look and see if anything's really close to a half. And in my head, I know 4/8 is equivalent to a half, and 5/8 is really close to that, and it is greater. So I'm going to put 5/8 over here and know that I'm done with that fraction. Then I'm going to ask the students, do you see anything that's really close to a whole? And I noticed that 9/10 is only 1 away from a whole, so I'm going to place it over here. Now this strategy is only good when you see that all of the fractions are spaced out pretty well, that none of them are too close to each other. So that's a perfect idea on how to take care of ordering them for that type of problem. Here's another example. I have 8/10, 2/6, and 4/8. Again, looking to see, are any of these fractions really close to 0? I see that 2/6 has not hit the halfway point, so I'm just going to place it on this side of my number line. Know that I'm done with that fraction. Is anything equivalent to a half or super close to a half? Well, I know 4/8. I know half of 8 is 4, so this is actually equivalent right to a half. So I'm going to put it right on that number line there. And then again, is there anything else that's really close to a whole? Well, I know that 8/10 is only 2 away from a whole, so I'm going to put it on this side. So you have easily been able to compare them and order them just based off of that all of these fractions, again, are separated and spaced out pretty well. Now, if they're closer to each other and you're not sure which is greater, you can always use common numerators. And what I tell students, you're going to get 2 pieces of pie, no matter what. You're going to get 2 pieces. Would you rather share with 6 people, or would you rather share with 9? And their answer normally is, well, I'd rather share with 6 because I'm going to get bigger pieces. Therefore, 2/6 is greater than 2/9 based off of common numerators. Another example of common numerators, I see that my numerators are both 6. So, talking about food is always good for kids. Would you rather have 6 pieces of pie and share with 8 people, or would you rather have 6 pieces of pie and share with 14? And again, they should say, well, I want bigger pieces, so I know I want to share with 8 people, so 6/8 is greater. Still working with common numerators where they aren't starting out the same, but I notice that I can make my 2 into 6ths, so I can compare it easier. And I'll ask them, well, how do you get from 2 to 6? And they'll say, well, I times it by 3. Do it to the numerator, you're going to do it to the denominator, so then I have 6/12. So now I can easily compare because they both have the same numerator. You're going to get 6 pieces. Would you rather share with 12 people or 9? And they're going to say, I'd rather share with 9 because I'm going to get bigger pieces. So changing the numerator to be the same is the perfect way to compare fractions. Then switching to common denominators, I notice I can't change my 4ths here to be 7ths, so I'm going to try, I see, oh yeah, I can change 6ths to be 12ths. Well, how do you get from 6 to 12? You times it by 2, do it to the denominator, do it to the numerator, and you now have 8/12. Would you rather have 8/12 or 7/12? The kids are going to say 8/12 is a bigger fraction. Much easier to compare when you have the same denominator. Another example, I noticed that my denominators aren't the same, but I could find a common denominator. So I could skip count in my head, 3, 6, 9, 12, but also be thinking about my denominator of 4, 4, 8, 12. Oh, that's the first, that's our least common multiple, so I'm going to change both of these to 12ths. How do I get from 3 to 12? Times 4 times 4, that's 8/12. How do I get from 4 to 12? Times 3 times 3, So here are our new fractions, 8/12 and 9/12. Notice the kids will say, wow, those are actually really close to each other, but I do know that 9/12 is greater. So it's always good to be sure of your fractions and compare them with a common numerator or denominator. Other options would be you could simplify to have the same numerator or denominator, or you could draw models, but honestly I would prefer models be your last option because you may not end up spacing it out correctly. So choosing one of my first options that I had here, I would highly recommend.